All right, welcome back to this video. And in today's video, guys, we want to look at iterators in Rust. But before we look at iterators, I want to beg you guys to take time and subscribe to my channel. Please help me. I can't beg you enough. Please subscribe to the channel and leave a like. If you like the video, leave a like. Please subscribe. Thank you very much. Now, let's look at the iterators in Rust. Now, if you come from languages like C++, you already have a clue about iterators. And iterators, basically, they help us run around arrays and strings, so to say, because strings can be represented or implemented as arrays or vector-like, depending on where you're coming from. And we have looked at static and dynamic implementations of strings in our previous videos, so you can check out the videos. Now, we want to look at iterators. Basically, what we want to look at here is how characters are stored in Rust strings and why they do not allow direct access. 2, we want to look at how to read string characters or string bytes using iterators. Now, before we dive deeper into that, we want to demonstrate something here. And the best thing we want to look at here is a string, and we want to navigate or iterate through that string and see what might come out. 0, 1, 2, and we want to look at these unique strings. I'll come here and pick, yes, this pound sign, put it here, but I also need this this character E, and I think I can get it here. Yes, I think I see it. Could be this one, maybe. Okay, so I want to put it there, and now I have a string. So now I want to iterate through this string and print out the ASCII representation values of these strings for at each particular position. So I'll do that using the for loop iterator. So for I, in 0, ... We've looked at ranges in Rust, and if you haven't watched that video, you can look at the channel. We've looked at those videos and making sense out of these ranges in C++, sorry, in Rust. So we need to print. We have said that we want to print out the ASCII representation of these respective characters. So we want to print out the position I, and then we want to print out as bytes. As bytes, why? It's some sort of like casting for these values into on each respective position. So the as bytes trait is basically performing some sort of conversion, and to be specific, what as bytes does, like, it converts the string to which it is applied into an immutable slice of numbers. So we need to know that such conversion has 0 runtime cost, because the representation of a string buffer is already that sequence of bytes. I hope that makes sense, but maybe by the end of the video it will be. So we cast that position to fathom the conversion. Now we have this iteration or the for loop, and it should be able to perform what we want. So we can call the Rust compiler rustc main.rs, and calling the main generated file, we see that we have for 0 at position 0, that means A is 97, B is 98, and C is 99. Now we see 0 is 48, and 1 is 49, and 2 is 50. Now we see that E is represented by 2 bytes, 195 and 169. And E is represented by 3 bytes, which is 226, 130, and 172. So that's something that is unique to the UTF-8 representation of ASCII characters. So so far for the characters ABC 0, 1, and 2, the ASCII value is printed here up to like these two value, and it is a single, double value. Now, this E character is represented by a pair of bytes, like I've said, and it has these respective values. Sometimes it could be 168, depending on the machine. And the euro sign is represented by a sequence of 3 bytes. That's why you're seeing these three bytes. So there is, if we are to get to a character in a given position, it is necessary to scan all the previous characters. Like if we want to find maybe character E here or this pound, you end up like you need to scan the entire string. And this sort of behavior is similar to text files, where you compare with the previous lines. For example, if you need to read a particular line, you probably need to scan the entire file until the last one. But of course, we know that that's sort of like a performance bottleneck. And what do we do if we want to scan a string? So let's look at another function here. So look at the function fn print, and basically what you want to do here is you want to print the sort of the nth character. And this is where we're going to demonstrate the use of iterators in Rust. So we have that string, and this is a string slice, the string reference, and n, which is a U32 maybe, and that's just an integer. It could be sort of like a position or a count value. Now we might need to make that mutable for some reasons, because it is going to change. And now we want to define our iterator. So we let, because it is an iterator, it needs to be mutable. So we mute iterator, and if we want to look at the type inference here at compile time, the iter is coming from the standard chars library in the standard library. So it comes from there, and you might not need to declare that, but maybe in this video we will. This is lowercase. Okay, so we have defined our iterator, and then we've looked at pattern matching in this course. If you go to the channel, we've looked at pattern matching in Rust, and you want to use the pattern matching paradigm of loop and match. And you want to create this sort of loop. If you leave it like that, it might be sort of like an infinite loop. So we want to look at an item. Let's declare an item, and this could be the item that you want to look at or move over next. So it is the next, the iter.next. So we're sort of like pointing to the next item, and this is an optional option type when it comes to type inference here. But you might not need to declare this. This should be optional. Now we look at the match. The match, if you remember, or if you've watched those videos, the match is like comparing items, and it's trying to look at through the items and to see which one is it. If it doesn't find it, it will continue to run. Now we use this keyword sum and sum C, where we are now looking at the sort of item that is coming up. Now in our case, we are iterating through a string, and we are observing each and every character depending on the count. So if we have n, which we declared here is the counter, sort of like, if n equals 2, in this case 1, what do we want to do? We want to print out that particular value. So print, okay, and we just want to print C, that very value. What else? We could potentially do something else. Now, we need the next block or the next part of this, the none, because something might not happen. What if it is not there? So we bring this none and we want to create a break. Once you reach a point and there is nothing, just exit. Basically, that's what we want. So imagine this as a countdown, and you count down to maybe the end, and once everything has been counted down to 1, that means we've reached the end of the string. Get out of the counting. Basically, that's what we need. So we use this count, but since we've said that this is a countdown, so you want to decrement the count from whatever number you're coming from. So we have that print nth character, and we said that we want to scan through the entire character and print the entire string, and print the nth character that you want to print. Now, to invoke the method, we really print nth char, and you want to print the string s. And that means we are counting from 1, but this is not a good example. Maybe we could say let s, maybe s1. Why do we even need to use that? I want here my e. Maybe I'll use this pound sign, the e, and that e. Maybe this will come after that. Yes. So basically, I want to print out the e, and we have s1. But remember, the function print nth char takes immutable value in the count. Since these are 3, I want to print the last one, so I'll put this to be 3. So my print value should be this last one, if all goes well. So I want to put some space here. Okay. Maybe I want that. So going back here, calling the compiler. Okay, I need a termination. Okay, that's good. And we call the main again, and voila, we get e printed out there, which is exactly what we expected. So what has happened here? Maybe we need to mute out this. Okay, I didn't want to do that. Control, yes, I wanted to do that. Now, maybe for proper visibility, we call the compiler again. Okay, so you see e is printed out, and we are really counting down from this position to the last element. That's basically what we are doing here in this iterator. So this iterator is doing that, like it is scanning through elements within the string, and it gives you the result that you need. So we can demonstrate this also when it comes to the ASCII codes or the ASCII characters. So using the because we know that the iterator has the next function, as we've seen here, this iterator. So every iterator has that next function. So that function returns the next item of the underlying sequence at the current position. I hope that makes sense. So it returns the next item of the underlying position or of the underlying sequence, sorry, at the current position. So, and then advances the current position, it moves it to the second position. So because we know that most sequences have an end, the iterators can return the next value only if they haven't reached the end of the sequence. So we want to use the match. Maybe let's see if we use the iterator to print out the codes like we did in this video here, in this for loop. So the function print codes still should take the string, and this is a different string or slice. And what do we want to do? We want to create a mutable iterator, and iterator should be mutable because it is going to change, as you've seen. So this equals to s dot characters, which is an iterator of characters. So we create this loop where we do comparison. In brief, we are doing pattern matching. Now this time around, we want to do the iteration from the current position to the next. So iter.next. Okay. And then we want to use the comparison sum c, and that pointing to, we want to do some printing for whichever value. That means you're going to print out everything. Now we want to print out everything, but we've said we want to print out the codes. So print ln line this time, because the other one really making things not visible. Okay. So we want to print out C, but also want to print out the ask character, and by doing that we sort of like cast as U32. So that's what we want to do for the first part of the iteration. And once we have finished everything, get out. Meaning get out of the loop. Otherwise, you'll end up with an infinite loop. Okay. So we come here, we invoke the function. We can print out that, and we say print codes and print string s1. Let's see what we end up with here. Okay. And voila. So we see that we are ending up with the character encoding for the ASCII encoding for these respective characters. And when you observe the function, it is iterating from the first s.character for that string. From that string, it is really upgrading, or like moving you from the first position to the second position to the third position. And you're printing out the very item with the corresponding ASCII character. If you come here, you will see that for the pound, the ASCII equivalence, this number here is 8364. And that's what we have here, 8364. So that's what I wanted to demonstrate. The key idea here is iterators, and we are having further videos on demonstrating how to use these ASCII characters and how they should be used. Not ASCII characters, but iterators, sorry. So how do you use iterators? And we're going to see them when you start building web applications. You see them the way they are being used in servers, and it's important to grasp these concepts. So thanks guys for watching. Remember to leave a like, subscribe, and see you guys in the next video. Bye bye.